Hello everyone, and welcome to XSTEM All Access. I am Meteorology, also known as the Hip Hop MD, and I'm excited to be part of this series, showcasing some of the most amazing and coolest minds in STEM. In this series, we'll dive deep into the diverse world of STEM careers and the individuals leading the way in science, technology, engineering, and of course, math. As your guest host for this episode, I am excited to chat with Captain Sophia Schwalbe. She is an ionosphere physicist at the Air Force Research Laboratory, and I'm going to ask Captain Schwalbe all the questions you'd like to know about her job, like what inspires her and what it's like to be a meteorologist for space. Make sure to subscribe in the YouTube description below and follow us on social media to get updates on new XSTEM episodes. You can also check out the full library of episodes available on demand right here. You'll find topics ranging from oceanography and engineering to chemistry and aerospace, and absolutely everything in between. Plus, educators can access NGSS and CASEL-aligned lesson plans to accompany each episode, including today's. These lesson plans are written by educators for educators. And of course, with your parents' permission, we'd love for you to tell us how you were inspired today by tagging us at USA Science Fest using the hashtag XSTEM and also tagging me at Hip Hop Science Show. Also, please join me in thanking our partners, the U.S. Air Force and the U.S. Space Force, for making this XSTEM series possible. Now, before we begin, let me tell you a little bit about myself because I'm sure you're all wondering. I am a science communicator with a background in civil and environmental engineering, and I started my hip-hop science platform to help spark curiosity and excitement in STEM by using music, entertainment, and comedy as tools to educate on a wide variety of subjects. I think curiosity is the key to unlocking so many amazing things in life, and I'm always excited to share fascinating things happening in the world of science, which is why I'm so hyped about our interview today, and I hope all of you are just as excited. I actually had the pleasure of meeting today's speaker in person last year, and trust me, y'all are going to absolutely love her as well. Captain Schwalbe is an ionosphere physicist who works at the Air Force Research Laboratory, or the AFRL. The AFRL is the primary scientific research and development center for the Department of the Air Force. They play an integral role in leading the discovery, development, and integration of technologies for our air, space, and cyberspace force. In her role, Captain Schwalbe is responsible for a team of 17 scientists and engineers that are on the forefront of magnetosphere research. I can't wait to hear about the cool things she has gotten to do as a physicist and early career scientist in the military. Captain Schwalbe, it is an absolute pleasure to see you again. And I want to jump right into our questions because I know the audience is excited to hear from you. As an ionosphere physicist, you work in a field that many of us either haven't heard of or know very little about. Would you give us a description of your role in the U.S. Air Force and the impact it has on the armed forces and the general public?
Thank you, Maynard. I am thrilled to be here today. I think you can think of me essentially as a meteorologist for space. Let me start by explaining what the ionosphere is so I can explain exactly what I mean by that, because I'm sure many of you are not as familiar with what the ionosphere is. Much like the Earth has layers, so does Earth's atmosphere. Most people are familiar with the troposphere, the layer of Earth's atmosphere that's closest to the Earth. That's where what we call terrestrial weather happens. That's your rain, your snow, your sleet, your hail, etc. Meteorologists spend their entire career studying this layer and studying the physics behind weather and being able to predict it. Well, there are multiple layers above the troposphere extending all the way into space, and each of them have unique characteristics according to pressure, density, temperature, and their interactions with the sun, because the sun actually emits particles and radiation. That radiation gets absorbed at different layers of the atmosphere. For instance, UV radiation can extend all the way through the atmosphere and cause you to get sunburned. That's why you're told to put on sunscreen. Luckily for us, these other layers also interact with different mechanics from the sun, especially between 90 kilometers and 400 kilometers in altitude. Energy from the sun there can actually knock electrons off of the atoms in this layer in a process called ionization. Hence, we call this layer the ionosphere. And much like the troposphere, this layer has a lot of dynamics to it, and something we call space weather. When you interact with the ionosphere, for instance, radio waves have to bounce off the ionosphere and back down to Earth, you can actually get a little bit of what we call scintillation. The signal gets distorted because there's so many different interactions happening. And sometimes you can even see these interactions. For instance, the aurora borealis are chemical reactions happening in the ionosphere that you can visibly see. In addition, you get things like GPS signals that have to go through the ionosphere from your phone to the satellite that it bounces off of in order to position you. And if the ionosphere is having a weather event, that signal can actually get disturbed. That's why sometimes on your phone, when you have a positioning app up, like Google Maps or Apple Maps, you'll actually see the position that it says you're in is not exactly accurate. And that's because the signal going through the ionosphere was disturbed. So my job in the military as a space meteorologist is essentially to learn what the physics of the ionosphere is and apply it to military applications. For instance, a lot of our soldiers use radio to communicate. Knowing how the ionosphere will affect those radio waves is crucial so that we can get our men home safely.
That is super cool. For anyone that's watching that's actually seen the aurora borealis, well, lucky you. It's literally on my bucket list of must-see events, so this just absolutely fascinates me. Now, most of us think about the weather here in our atmosphere on a daily basis, but the concept of space weather takes it to a whole new level. Now, I check my phone app every day just to see the weather conditions, and now I'm actually wondering if someday our favorite weather app might be able to notify us about storms in the ionosphere. That would be pretty incredible. And speaking of space weather, how did you discover that you wanted a career in space physics, and even more specifically, the study of the ionosphere and the magnetosphere?
So how I got into space physics is actually a bit of a story. I've been interested in physics for a while, actually since my freshman high school physical science class. One of the projects we had to do was write a paper and a presentation on any topic in science. It could be whatever we wanted. We had people doing prosthetics in the medical field. We had people doing physical chemistry. However, I discovered something called dark matter and dark energy. Essentially, the matter that you and I are made of only accounts for 5% of the universe. The rest of the universe is made of things called dark matter and dark energy. Now, let me explain what those are. Dark matter was hypothesized because an astronomer was observing distant galaxies. In those galaxies, you can determine the mass based on how much light is emitted. And from that mass, you can determine how fast those galaxies should be rotating around, sort of like a spiral. Well, this astronomer discovered that the galaxies were actually rotating much faster than they should have, which meant that there was missing mass. Hence, dark matter had to be hypothesized as matter that we can't see, but that must exist in order to account for this discrepancy in speed. Dark energy, meanwhile, was hypothesized because astronomers were looking at very distant galaxies again, but they were measuring how fast they were moving in relation to us in the Milky Way. But they discovered that, unlike what they hypothesized originally, that the galaxies should be moving closer due to gravity, they discovered they were moving farther away and really fast, which means that they were accelerating. And for those of you who are familiar with Newton's laws, acceleration means that there's a force and therefore an energy behind it. So they had to hypothesize that some energy was causing this acceleration, and therefore they determined it was dark energy. They still don't know what it is. But I was so excited about the fact that there was 95% of the universe that we just don't understand and we don't have a good explanation for. So I decided that I really wanted to go into space physics and be a part of this. Meanwhile, my dad was actually an Air Force officer himself, and I was really inspired to follow in his footsteps. So I had to kind of combine my dreams of doing something with space with being in the military. And I discovered that space physics is really important, especially now with the stand-up of the U.S. Space Force. So I focused on space physics in my undergraduate curriculum. When I graduated, however, I got the opportunity to go to the Air Force's graduate school, the Air Force Institute of Technology. And while I was there, I talked with some of my professors and actually was supposed to go into the nuclear program. I said I really wanted to do space, and they ended up finding me something that actually married the two. So my master's thesis ended up being on high-altitude nuclear detonations and their effect on the ionosphere. And ever since then, I've been heavily invested in the space weather field.
I love that so much, Captain, because it literally doesn't matter, pun intended, what direction you go in. You can always find unique ways to combine your passions. And that's actually very similar to what I've been able to do with my platform. I always had this love for music and entertainment, and I never really knew where science actually fit in. And I think it's really great for anyone that's tuning in right now that there's never just one lane or path that you have to follow. You can have multiple interests in different things, and who knows, the career you end up with might be something that doesn't even exist. You have the ability to literally carve your own lane in any direction that you want to go. So that is absolutely inspirational, not just for me, but for everyone that's listening right now. And Captain, you hold a Master's of Science degree and a PhD. For many students, that amount of school might sound a little daunting. So how did you stay motivated and focused throughout your education?
Staying motivated and focused for 2 degrees over the course of 4 years, I'm not gonna lie, it was very difficult. It was a very challenging journey, and there were times where I was quite down about it. I thought about giving up or switching to something easier like math. But I was able to stay focused through a few different techniques. And the first of that was I was very fortunate and I was able to take a lot of mental health breaks. For me, when I was in my coursework, I had a lot of flexibility with my schedule. Of course, I had my classes at specific times, but the rest of the time was up to me to do homework or study or do my research. However, if I was starting to feel really burnt out, I was able to take that time and just give myself a day or so to decompress, to rejuvenate, renew my efforts, and then I was able to go back to it the following day. I was also very lucky in that the Air Force actually paid for me to go get these degrees, so I didn't have to worry about my finances as much as some other graduate students have to. I was still getting my full salary and getting school paid for. Of course, there's always the temptation to take more time and just not go back to it. What's 3 or 4 days here or there where you're not doing school, right? But that's where my second technique came in, remembering my end goal. I knew early on I wanted to get a PhD. That's something I've wanted for a long time. And there were also repercussions if I didn't finish my PhD. So I knew that I had to finish. And it's really motivating, at least for me, to always say just a little more, just push a little harder and then you'll get there. And then when you have that degree in hand, it's done. You never have to touch it again. But the last secret technique that I had was that I had a great support system. I made a lot of friends in both undergraduate and graduate school, and I have an amazing family who really helped me out. Not everyone will understand what you're doing, especially if you're going for these degrees. A lot of them will say, is a PhD worth it? Why are you going for so much school? But if you can find a few people who really get it and want to support you, those are the ones you want to keep in your life, and those are the ones you want to be on your team.
I can't be the only one that caught that when Captain Schwalbe said she considered switching her majors to something easier like math. Not said by many people, only you, Captain Schwalbe, I love it. But you really brought up a great point about finding time to recharge and re-energize. And I think that's something we don't commonly associate with education, right? We're always told to go, 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 knock out your classes, get straight A's, graduate. But learning doesn't come easy for everyone. It actually took me about 5 years to graduate with my engineering degree. And I felt for a while like I was a failure because I didn't finish in 4 years like many other students. But I look back at it, and taking that time to get through those courses really allowed me to focus in and get more hands-on experience and internships. And I think it ultimately set me up for better success once I graduated. So finding that balance, however you choose to do it, is really, really important. So next question, Captain Schwalbe. Would you take us through an average day at your job?
Well, that's the thing, Maynard. I don't have an average day. So I currently work at the Air Force Research Laboratory in the Space Vehicles Directorate. And I love my job purely because there is something new all the time. No 2 days are the same. There's always new science, new ideas, and new things to learn. I suppose on average, my day starts with checking in on the people that I supervise, the people who are doing really good research in the ionosphere and magnetosphere, my colleagues. Then I check on emails and make sure that I'm not missing anything. We get a lot of taskers from leadership. I have a lot of contacts with other bases, other military folks. I make sure that I'm keeping all of my to-do tasks checked off and seeing what new things come in for me for the day. Then I start working on the next task for my project. I use my technical degree to do program management for a huge scientific experiment. So I'm always working on documenting, planning, managing all the good science technical work. Sometimes I get to go to scientific lectures or conferences from people around the world presenting their research. And sometimes I get to interface with our senior leadership on policy and where we are going to go with the science and technology for the air and space forces. I also get to travel a lot. My job takes me everywhere in the world to talk with both the military and with other scientists. I'm always very lucky to be constantly engaged and busy.
That is an incredible combination of science, policy, travel, and collaboration. And I doubt that many of us connect that job description with the US military. So, for anyone watching, a career in the military doesn't just lead to a combat role. If you want to see the world and meet with incredible scientists across the globe, you can do that too. Now, diving a little deeper into your job, can you tell us experiments or research you're working on now that you find especially interesting or even exciting to be a part of?
Hmm. There are so many to choose from. Let's see. So, one of the things we get to do at the Air Force Research Laboratory is we get to have a lot of collaborations with different university partners, different government agencies, etc. We do a lot of outreach and we like collaborating as much as possible because that's where the good science comes from. Well, one of our collaborations is with a place you may have heard of called DARPA. It's the Defense Advanced Research Projects Agency. It's a government agency that you might know for, inventing the internet. We have a very good relationship with DARPA here at the research labs. So sometimes we get asked to help out with some of DARPA's new thoughts and experiments, their new projects, just the next internet or something like that. One project we're working on is something called AtmoSense. It's using the atmosphere as a sensor for things happening on the ground, which is really interesting because, for instance, say a volcanic explosion happens. Well, scientists have actually measured that those eruptions can actually travel all the way to the ionosphere and be measured there from the reflections off of it. It's really fascinating to me, especially since some of our scientists that are working with DARPA and AtmoSense have actually just measured lightning off of the ionosphere. How cool is that?
I just recently saw a video on my IG of a lady that captured a lightning storm in the middle of this huge volcanic eruption, and it was literally one of the most amazing things I've ever seen. Not the place you probably want to be up close, but still incredibly fascinating. Now, speaking of research, can you walk us through what the process looks like for conducting field experiments?
Our field experiments aren't terribly different from what you would do in a school experiment. We start with a question. What are we trying to answer with this field experiment? Typically, for instance, if we put out an ionospheric sensor, our question is, what is the ionosphere at this location doing? What is the physics in this particular location? Then we have to make a hypothesis. What do we expect the answer to that question to be? And that actually helps with our planning. We spend a lot of time working on the hypothesis because, for instance, for us, a lot of ours is location dependent. If we're asking the question, well, do we expect to see something in the ionosphere happen at this specific location? We have to have a hypothesis of where this location is in order to plan. Finally, once we have that hypothesis, we come up with the procedure. And this is probably where we differ the most from your typical school experiment. Our experiments typically involve anywhere from 4 to 14 scientists, and that's on the low end, and are typically not located anywhere close to the Air Force research labs. As they said, it's a field experiment, which means we get to go out in the field all across the world. But this also means that there's a lot of planning involved. I spend a lot of time in this particular area working on the procedure because I have to coordinate the travel, the locations, the people that are going to host us, shipping the equipment and instruments, finding out what data we need to collect from those instruments, and then finally, all doing this within a certain budget and time period. Finally, we get to do the fun part, conducting the experiment. We send our scientists out into the field and they set up the sensors. Now, for us, most of our experiments are passive. So once we set up the equipment, we just get to sit and watch. Finally, once that time period of collection is done, our scientists pack up the equipment and come home. And then they have to do the hard part, which is the data analysis. Because remember, we are still answering a question. So they have to go through all of this data that they've just collected and find that answer. Sometimes they'll actually discover something they didn't expect, which may generate new questions and then new field experiments. And finally, at the very end, we'll publish our results, either internally in a technical report, or we'll release it to the public in a journal article, which you can actually find multiple articles from the Air Force Research Labs online.
I have a phrase that I state in all of my videos: curiosity is nature's PhD. Never stop asking. So it's pretty awesome to hear how using the scientific method and asking questions led to some pretty amazing field research for you. So that actually leads me to my next question. Have you encountered any roadblocks or obstacles on your career path? And if so, how did you overcome them and how did they affect the person you are today?
Oh, there were so many obstacles. I'm not gonna lie, getting to where I am now was a marathon, not a sprint. And there were times I thought I wasn't gonna make it. I'll start with the one that every high school student is probably dreading: applying to colleges. I desperately wanted to get into this one particular elite school that I won't mention by name on camera, but I was almost instantly rejected as soon as I applied. It was really soul crushing to me, actually. And then shortly after, my number 2 waitlisted me, and I was really let down by that. But my number 3 accepted me, and I pulled myself together and said, I'm going to go, I'm going to make the best of it, I'm not going to let it get me down. And it ended up being the right choice for me. This school was actually smaller, so I actually had one-on-one classes with my professors instead of being in large auditoriums with hundreds of other students. I didn't have teacher's assistants, so I could go straight to my professors and they knew me by name. And I also got to be involved in the Air Force Reserve Officer Training Corps, or AFROTC, which is how I ended up in the Air Force. And the unit at my school was one of the best in the country. So ultimately, it was a good experience for me and I made the best of it. But if I had really let those first 2 rejections get me down, I don't think I'd be here. I also didn't quite learn that you could call undergraduate admissions offices, like they mentioned in Spider-Man No Way Home, until way after this, and I kind of kicked myself for not having done it. But I did do it for graduate school. You see, when I applied for graduate school, actually my application got lost in a paperwork snafu. I was so upset. I really wanted to go to grad school, and this was almost one of the only opportunities I would have. So I actually called up the commander of my AFROTC unit and asked him to intervene to see if he could try to fix the paperwork issue. And because I had been a good cadet up until that point, he agreed, and I was able to go to grad school because of it. But I did learn 2 important things from these experiences. One, if you are kind and polite and have a professional image and just do your best, people will notice. They'll be more inclined to help you if you get into a bind. They'll be more willing to help you over those obstacles you might face. And 2, persistence will get you incredibly far. You might need a little help at the end, but having that drive, that motivation, and that determination to see it through will serve you well. And that's what people will remember about you.
Yes, sometimes obstacles change our path for the better. And it's kind of crazy because I actually went to school originally to study wildlife biology. I ended up going the engineering route because I met so many peers and educators even that told me there weren't any opportunities to succeed in wildlife biology. But I still never lost my love for nature, and I kept learning and staying invested in what was happening in wildlife discoveries and conservation efforts. And now, come full circle on my platform, a lot of my content actually has to do with amazing biological topics and has even led me to spending a month out at sea and doing work with rainforests and coral reef protection and all sorts of different wildlife organizations. So I always say stay determined and focused on what you're passionate about. And if you truly, truly love what you do, there will always be a path for you to be successful at it. And along with that, you always need a good support system along the way, right? So did you have any role models or mentors that guided you throughout your education and ultimately in achieving your career?
I've actually been very lucky to have a lot of role models and mentors throughout my entire journey, starting from high school and continuing up until today. In high school, I was very lucky. I had some amazing science teachers who were incredibly supportive of me wanting to go into STEM. When I told them I wanted to pursue physics, they were quite eager and tried to help me out as much as possible. When I was in undergrad, I had an incredible instructor who I'm still in contact with today in the Air Force Reserve Officer Training Corps. He was able to mentor me and guide me even when I was really struggling with some personal issues in college. He took the time to gently guide me and encourage me, and he even submitted me for awards because he thought that I was doing really well. And just that little bit of encouragement really went a long way for me. When I got to graduate school, I was also really fortunate because there were a lot of women there at my graduate school that were officers and scientists. As you may have noticed, I present as female, as a woman, and there aren't very many of us in the military and in STEM. So being at graduate school and seeing these amazing women as professors and scientists and senior officers was really inspiring to me, and they took the time to mentor me and encourage me to continue with my studies and be a better officer for the Air Force. I also got mentored by some other very stellar officers who took me under their wing and gave me some opportunities I would not have had otherwise. One of my mentors, who I'm still in contact with, got selected to be a part of the Defense Advanced Research Projects Agency, or DARPA, and he was able to give me actually my master's thesis topic. I'm still in contact with him today, and we still do great collaborations on science and technology now. Now that I am at the Air Force Research Labs, I'm also trying to pay it back. We have several young officers and scientists here that I try to mentor in return for the good mentoring that I had.
For any student listening, I absolutely encourage all of you to find mentors or role models throughout your academic and professional journey. It can be everything from teachers, family members, friends, or even STEM professionals on social media that you admire. Trust me, they'll go a long way in helping you better understand the right direction to take and also giving you the confidence that you need to be successful in any career path that you choose. Okay, Captain Schwalbe, we have learned so many cool things about your career as an ionospheric physicist and meteorologist for space, but I'd love to know as we get close to wrapping up, what do you enjoy the most about your job?
That's a really hard one. There are lots of aspects of my job that I really enjoy, and picking just one is quite the challenge. On one hand, the people at the Air Force Research Lab that I work with are incredible. I hear lots of stories about toxic work environments from my friends. I hear about bad coworkers, workplace drama, bad bosses. But I have been very fortunate here at the research lab to work with a team of incredibly smart people that really care about the research and really care about each other. There's a whole team here that is dedicated to increasing the science and technology capabilities for the Air and Space Force. We're all very dedicated to the mission, which means that there's very little drama and everybody tries to get along as much as possible because we're all on the same team. I get to come into work, I ask them about their research, and then they go on a whole diatribe about what they're doing, and it's really amazing to see the passion that they have for their topics. On the other hand, I also get to do a lot of travel for my job. I've been at my job for just over a year now, and I've already been to 6 different countries in that time alone, and just for work. Now, I'll admit, flights were awful. They're foreign countries, and flights internationally can be kind of a slog. But once I'm there, I get to experience so many things that I wouldn't have otherwise. I love being able to experience other countries, other cultures, and eat all the really good food. So it's hard to say, but I really just love being here.
I love the quote, when you find your passion, it becomes your purpose and you can no longer be passive. And you are clearly passionate about your work, and I find it personally so uplifting. But before we close, can you offer some advice or simply just words of wisdom for the aspiring physicists and researchers that are watching this interview today?
So I got this one from my mother, and I'll pass it on to all of our viewers. The squeaky wheel gets the grease. It's one of those charming, old-timey idioms, but I've actually found it to be really true. Make it known what you want. I started saying that I wanted to go to grad school really early on when I was in college. And my mentor noticed, and he started looking for opportunities for me to go to grad school that he didn't even know about. In fact, I think I was one of the first cadets from my program to actually go to the Air Force Institute of Technology, the Air Force's grad school, because nobody else had ever expressed an interest in going. That's also how I got into my PhD program. I went to the department chair multiple times while I was there and said, I want a PhD. And I said it so much and so often, I think he got annoyed and finally just said, fine, you can get a PhD. Just stop bothering me. Part of it is also knowing when you need help. I didn't learn that lesson for a long time, and I wish I had learned it earlier because it would have saved me a lot of trouble later. It's okay to ask for help. People are really glad to help you for the most part, as long as you give it a try first. Use your professor's office hours. Ask questions in class if you don't understand something that was said. Ask about your professor's research. If you express an interest and they understand that you understand what they're doing, they might give you a research opportunity that you wouldn't have had otherwise if you hadn't asked. There are lots of opportunities, but you'll have to work really hard and you'll have to look for them. They won't just happen to you. So always be really vocal about what you want and what you want to do.
I couldn't agree more, Captain. It is absolutely okay to ask for help. A simple question or just letting somebody know what you're interested in can open so many doors for you. And with that being said, I couldn't think of a better note to end our conversation on. I want to say thank you so much, Captain Schwabe. I absolutely love chatting with you today and hearing about your work at the Air Force Research Laboratory and, of course, your passion for studying weather in space. It is so inspirational. Thank you for being you and bringing your passion and, of course, for everything that you do for our country.
Thank you so much, Maynard, for having me today, and thank you to all the students for joining me. I hope you were able to learn something, take something away from this, or maybe even be inspired. I hope that you will check out the Air Force Research Laboratory. Speaking of opportunities, we actually have some summer scholar programs if you want to get involved.
Speaking of cool jobs in the Air Force, let's watch this brief video to see some more. Make sure you check out the Air Force and Space Force online and follow them on social media to keep up with all of the amazing things that they're doing. And thank you so much for tuning in today. Make sure to subscribe to the YouTube description below and follow us on social media to get updates about new episodes. I guarantee you won't want to miss any of them. Plus, you'll get access to fun weekly content for students and teachers, such as STEM trivia for students, classroom tips for teachers, and so much more. And don't forget to check out the full library of episodes available on demand right here. Each one has an NGSS and Castle-aligned lesson plan for teachers to use in the classroom. With your parents' permission, we'd love for you to tell us how you are inspired today by tagging us at USA Science Fest using the hashtag XSTEM and also tagging yours truly at Hip Hop Science Show. You can also keep up with me and the work that I'm doing with my platform through my website and social media here. Everything from educational online videos to how you can collaborate with me for in-person workshops and STEM outreach projects. I had an absolute blast being your host today, but don't sign off just yet. You want to stick around through the end of this video for a fun trivia game that you can do in the classroom or at home. Have fun, everyone. Peace.